Okay, we're starting back up with the 11.1 through 11.3 view, this one right here. But we're on number 10. There's already a video for 1 through 9 right before this one. So look for a number. We're starting at number 10. It says rewrite each polynomial as a product of linear factors and tell me the zeros. So I'm not sure what this is. All right. So we're going to rewrite this one as a polynomial as a product of linear factors and tell me the zeros. All right. So this one has a GCF, right? But if you take a GCF out, it's going to be x squared plus 4. And you still can't factor that because it's sum of two squares. So off to the side, we're going to take x squared plus 4. We're going to set it equal to 0. And then we're going to subtract 4. Then we're going to take the square root of this. Make sure you put the plus or minus in. And this is plus or minus 2i. So we're going to rewrite this as a product of factors. So 10a, I'm going to write it down here. 10a is f of x equals the 2, that's the GCF, x minus 2i, x plus 2i. And that's it. So the next one, we're going to attempt to factor this. So it looks like we're going to have 2x squared and x squared. Factors of negative 9 are 3 and 3 are 9 and 1, but we need it to be a negative 7. So I think I'm going to put a 9 here and a 1 here. Because, and that's a negative 7, so I want the bigger product to be negative. So that's negative 9. So you check your OI, negative 9 and 2 is negative 7. So you need to be able to factor. Then you take each factor and set it equal to 0. So you have 2x squared equals 9, x squared equals 9 halves, and then square root, plus or minus. So the square root of 9 is 3. The square root of 2 is the square root of 2. Okay, so if you break that fraction apart, square root of 9 is 3. Square root of 2 is radical 2. But you have to rationalize this by multiplying top and bottom right radical 2. So this is plus or minus 3 radical 2 over 2. The other one, if you take this one and set it equal to 0, you subtract 1. I'm doing a video. What do you need?
You know those autism playgroups that we have?
Autism papers?
Playgroups, like
Yeah.
in church. She wants us to do like a toy drive or help her get some toys. Do you have like a cardboard box at your house that we can use to put toys in instead of like throwing them in your room or something?
Springboard boxes. We might be able to get some springboard boxes across the hall.
Okay.
Let me text Mr. Oakes and see if he's got some springboard boxes.
Okay.
All right.
Text me and let me know.
Okay, I will. So x equals plus or minus I. So if you're going to write this as a list of factors, it's f of x equals, let's start with the i's, x minus I, x plus I, then x minus 3 radical 2 over 2, and x plus 3 radical 2 over 2. And that's it. So C. And C, we're going to take a GCF of x out, and you get x cubed plus 8. This one is x plus 2. This is a trinomial. This is going to be x squared minus, remember the sign, so plus or same, opposite. Multiply these two, you get 2x, and then always positive 4. So x cubed is xxx, 2 and 8 is 222. Take one of each of them and put it here and here. Multiply those to get the middle term, and then there'll be 2 x's left. They go here. 2 2's left go here. So these are the factors, but this is not linear factors. This is a linear factor, and this is a linear factor, but this is a quadratic factor. So we would have to do the quadratic formula for this. Holy crap, I need more room. So I'm going to go to some pink paper here and do quadratic formula. So x squared minus 2x plus 4. A is 1, B is negative 2, and C is 4. So the quadratic formula would be the opposite of B, 2, plus or minus B squared, which is 4, minus 4 times A times C over 2 times A. 4 minus 16 is negative 12 over 2, which is 2 plus or minus 2I radical 3 over 2, which is reduced to 1 plus or minus I radical 3. So these two zeros right here. So I'm out of, there's no room for this problem. All right, so one linear factor is x. The second linear factor is x plus 2. The third linear factor is x minus parentheses 1 plus I radical 3. Parentheses, parentheses. And the other one is x minus 1 minus I radical 3. So these are your 4 linear factors. That's a really hard problem. All right, so now I'm really out of room for D. So there's the quadratic formula for C again. All right, so D, I might have to do another post-it because I'm like out of room. I'm going to have to add this post. I don't know how I'm going to put this in the answers. Let me see. Quadratic formula. We've got 2 plus or minus 4 times 4 over 2 equals 1 plus or minus I radical 3. I'm just going to write that for the answer key. All right, D. I have no room now, so I don't know where I'm going to do this problem. How about we go up here? We have 3x cubed plus 18x squared minus x minus 6. I'm factoring by grouping, so it's x squared, which is x plus, I'm sorry, it's 3x squared, so it's x plus 6. Take a negative 1 out and get x plus 6. I feel like I just did this problem in the homework. So this is x plus 6, and then 3x squared minus 1. But again, this is quadratic, so you're going to take this one, set it equal to 0, and solve. 3x squared equals 1. X squared equals 1/3. Come over here. X equals, take the square root of both sides, plus or minus, radical 1/3. Square root of 1 is 1. Square root of 3 stays a radical. And then you have to rationalize. So it's plus or minus radical 3 over 3. So your linear factors, f of x equals, come up here. We had this, remember this x plus 6? That's still one of your linear factors. The other two are x minus radical 3 over 3 and x plus radical 3 over 3. That was a homework problem. That was the homework problem from section 11-2. Man, those problems are not fun. I did not enjoy those. 11. Find all the zeros of the function given the complex 0, 1 plus 2i. Okay, so we're going to do it the long way. So we're going to start by setting x equal to 1 plus or minus 2i. Because if 1 plus 2i works, then so does minus. Then we're going to set this side equal to 0. So we're going to go x minus 1 equals plus or minus 2i. We're going to get rid of the plus, minus, and I by squaring that side. And if you square the right side, you must square the left side. We're going to FOIL this side, x squared minus 2x plus 1. If you square plus or minus, it's positive. If you square 2, you get 4. If you square I squared, you get 4i squared, which really is a negative 4. We're going to add this to the other side, and we get x squared minus 2x plus 5 equals 0. Then we're going to do long division. That's the quartic. This is the quadratic. Your steps are divide first terms, then multiply, then subtract, then bring down. So we're going to divide the first terms. What's x to the fourth divided by x to the second? The answer to that is x to the second. So then we take x to the second times x to the second and get x to the fourth. X to the second times negative 2x is negative 2x to the third. And x to the second times 5 is 5x squared. Now we're going to subtract. When you subtract, I need a different color marker so you know that I've done this. Oh, I don't think I have one. I have purple. when you subtract, you're going to change the signs like this, and you're going to add. So these cancel. 2 plus 2 is 4x cubed. Negative 8, negative 5 is negative 13x squared. Bring down these last two terms. So this is your new, oh my gosh, this is your new dividend. So we're going to start all over again. We're going to divide first term. So what's 4x cubed divided by x squared? 4x. We're going to multiply 4x to x squared. 4x times negative 2x. And 4x times 5 is 20x. We're going to subtract. So when you subtract, I'm going to do it with a red marker this time. When you subtract, this is minus, plus, minus. So add. Negative 13 plus 8 is negative 5. 30 minus 20 is 10. Bring down 25. So this is the new dividend now. So now we're going to divide one last time. What's negative 5x squared divided by x squared? And it should be negative 5. I should be done right now with that trinomial, but I'm just going to check to make sure I got a zero remainder. So negative 5 times this is negative 5x squared. Negative 5 times negative 2 is positive 10x. And negative 5 times 5 is negative 25. And if you change these signs, you get a zero remainder. So this is a root of that polynomial. So now, you're going to take this trinomial and you're going to factor it. X plus 5 and x minus 1. So when it says what are the zeros, one of your zeros is negative 5 and one of them is 1 if you set those equal to 0. So your zeros are negative 5 and 1. We just found them. And 1 plus or minus 2i. Those are your four zeros. You could punch this in the calculator and see that it crosses negative 5 and 1. But you would have missed all this fun. Look at that fun. That's so much fun. All right, sorry that this is like diagonal. I don't know why I was writing diagonally. So 12. Find all the zeros of this one. This one we're going to do with synthetic division. Or this one we're going to do with synthetic division. So we're going to take negative 3i. And we're going to plug it into this synthetically. 1, 3, 9, and 27. If you don't want to do synthetic division, you can factor this by grouping. They're both going to work. So you can factor by grouping or synthetic division. I just love synthetic division, so I'm doing synthetic division. So 1 times negative 3i is negative 3i. So this is 3 minus 3i. Then if you multiply negative 3i times 3, maybe this is not a good idea to do this. Negative 3i times 3 is negative 9i. Negative 3i times negative 3i is positive 9i squared. And positive 9i squared is really negative 9, so that cancels that, and you're left with negative 9i. If you multiply that, you get 27i squared, which is really negative 27, and there's your 0. So I guess it's not that easy to do this with synthetic division. But I'm not going to stop because I'm already in the middle of it. So bring down the 1. 1 times 3i is 3i. What cancels? Boom. You're left with a 3. 3 times 3i is 9i. That is 0. So this started as a cubic. This was quadratic. This is linear. So take and put a variable in, 1x plus 3. Set it equal to 0, and your third root is negative 3. So find all zeros. They're plus or minus 3i and negative 3. I think some of you guys are probably bailed on that one, so let's go to the factoring part of this. What's the GCF? Okay, if you take an x squared out, you get x plus 3, and if you take a 9 out, you get x plus 3. Bring the x plus 3 out here, and you get x squared plus 9. And if you set this one right here equal to 0, you get your real 0, x equals negative 3. That's a little bit easier, I guess. And then these two, we're going to give you the plus or minus 3i. So there's your zeros. Solve the inequality and write the solution interval. We're going to make this greater than 0. And we're going to solve by taking a grouping. Let's do this by grouping. We're going to find the zeros. We have x squared, x minus 1. Take a negative 4 out and get x minus 1. And your factors are x minus 1 and x squared minus 4, which is x minus 1, x plus 2, and x minus 2. All of these factors are greater than 0. So now we need a number line. So one of my zeros is 1. One of them is negative 2. And one of them is 2. But these are going to be open circles because it's just greater than 0, not equal. So they're just there. This divides us into 4 sections. So which section works? So this section over here is negative infinity to negative 2. This section is negative 2 to 1. This section is 1 to 2. And this section is 2 to infinity. All parentheses because there's no closed circles. I'm going to test in a 0 to this thing right here. If you throw in a 0 here, 0, 0, 0, you get 4. So up here, if you test 0, you end up with 4 is greater than 0. That is true. So to me, that means the 0 section works. That means this one does not work. Means this one does not work. So every other one works. That means this one works. So our answers are these two. So it's negative 2 to 1, union with 2 to infinity. If you graph that on the calculator, just for fun, you guys are probably saying, don't do this, it's taking too long. X squared, but you can't put a price on understanding, right? Graph. Oh, I think I just messed up. I meant zoom 6. I feel like I did something wrong with my white goals. Let me see. Nope, that looks good. All right, where is it greater than 0? This is what it's asking. Is this problem? Did I punch it in right? Oh, I didn't punch it in right. Whoops. I kept thinking something looked wrong. I forgot the 4. I'm going to insert. Second insert 4. There we go. Now it should make sense. All right, so you should be seeing the zeros that we saw. Negative 2, 1, and 2. That makes sense, right? Negative 2, 1, and 2. There's the zeros. They wanted to know in this problem, when is it greater than 0? So it's greater than 0 here and here. So between negative 2 and 1, that's what we wrote. And then again after the 1, or after the 2, sorry, after the 2. And that makes sense to our graph. Boom. So this next one is just x plus 3, x minus 3. When is it less than 0? So our zeros are negative 3 and 3. And we went open circles on these. And it divides it into 3 sections. So we're going to test 0. 0 squared minus 9, is that less than 0? Negative 9 is less than 0 is true. So 0 does work. So our answer is negative 3 to 3. Done. That means the other two do not work. If you want to see what that looks like, you know you do. X squared minus 9. When is this graph less than 0? When does it fall below the x-axis between negative 3 and 3? Done. Look at the graph and tell me the solution intervals when f of x is less than 0. So when f of x is less than 0, this is less than 0, and so is this. Okay? That's when it's less than 0. So we just have to write the interval. So we need to know the 0. That looks like it's crossing at negative 3. So I would say from when is it less than 0, not equal? So we're going to do parentheses. From negative 3. Oh, wait. It's from negative infinity to negative 3. It's from negative infinity to negative 3. It's from here to here. Then it's greater than. Don't use that. Then it's less than. So it's less than from 0 to 1. From 0 to 1, it is less than 0. They're not asking when it's less than or equal to. That's why we're not using brackets. That's it.